Hello and welcome to the problem set that I gave as a prep for the mastery test. I wanted to go through some of these with you. A couple quick things to note before we get too far into them. These are not exactly like the problems that you're going to see in the mastery test. I'm choosing not to give you exact problems because, quite honestly, the problems are going to change from test to test. Instead, we're going to be looking at problems that model the exact methods that you would use to solve those problems. I'm going to go through and I'm going to show you some of the methods that I use. I'm going to show you some of the ways that I would solve some of the problems. It's important to note that some of the things that we're doing will in fact change as we get going. That there's things that I'll say I'm going to solve using the fact that two lines cross on the inside of the circle. Sometimes I'll choose to solve them using the various triangles and things along those lines. I will try and show you multiple methods, or at least talk through multiple methods, but understand that it's a lot of these problems could be done in multiple ways. Could be done in lots of different important ways. Alright, so let's start with question 1. The first thing that I want us to look at is the fact that this arc right here is an unknown. Now, there's a lot of ways for me to get to the measure of that arc, but I'm going to choose to use the fact that this angle here creates both this arc and that arc. So that means that the measure of this arc, which I'm going to call x, is in fact equal to, or excuse me, the angle involving that arc x, 20, is equal to 1/2 of x minus 96. Okay. Now, I can go through, I do all that solving, multiply by 2, 40 is equal to x minus 96, and we get x is equal to 136. Now, there are other ways I could have gotten to that, but I like using that method because now, as I go through and I figure out the rest of these pieces, I can actually use that 136 to solve for. Right, case in point. I know that this is 96 degrees, this arc. Well, that arc, if I look, it is actually formed by this angle here, which then means that it's inscribed angle divided by 2, so that's 48 degrees. And lo and behold, it is in fact formed by that angle as well. So now that's 48 degrees. In fact, I'm going to leave those degree marks off, excuse me. Alright, so I've got that. Well, now, if that is 85 degrees on the inside, then that means this is 47 degrees. And that's 85, and then subsequently 47. Well, let's see here. A couple things that I know. Well, if this is 47 degrees, and I notice that that angle creates this arc here, just this one in the middle here, that means that this is 94 degrees. And because earlier I found that this is 136, then this has to be 42 degrees. A couple things that I can use or go from there on. Well, I know that I have an inscribed angle right here, and that inscribed angle, in fact, creates that arc. So I know that half of that 42 is 20. Is 21, and then I see that half of that angle in here is 21 as well. Alright, so I've got that. Let's see, I need to also solve for these angles. Well, that's 85, that's got to be 95, that's got to be 95. And I can go in, I can check here and say, okay, well, there's 360 degrees in this circle, so if I take 360 minus 96 minus 42 minus 94, then that's going to give me 128. I take that 128, I notice that I have an inscribed angle right there, and that 128 divided by 2 gives me 64. and then that also means that would be 64. A couple things that I can go through and check very, very quickly, just to make sure that I've done this correctly. I should have this triangle add up to 180 degrees, and 95 plus 21 plus 64 is in fact 180, so I'm good. So, fairly quickly went through and solved this. It's important to remember that as I go through and solve it, as once I get one value, I should be able to use that to parlay into the next one, and into the next one. And there are some of these problems that you're going to see that require multiple values. So the trick is to go in and start in one spot and then just keep on working through until you get to that right answer. You will find that your ability to do that will be greatly rewarded purely in the ease in which you can actually solve some of these problems. Okay, so this is question number 2. A couple of things that I should see right off the bat. And that is, the first, of those is the fact that that is the center. Because that is the center, then that makes this a central angle. So this 114 degrees is in fact the same right here. That means that this central angle as well is 66, because there's 180 degrees in a line, and then that central angle creates this arc of 66. Well, I have that same thing occurring here. So 114, 66, and I should be able to find those arcs. Now, this 114 in fact makes this large arc here, of which I know that 82 degrees is in this arc. So 114 minus 82 will give me this little chunk, which is 32 degrees. From here, I'm just going to start backing into my various inscribed angles. I'm going to start on this arc and move to that angle, and we'll walk our way around. This is 32 degrees. It goes into that inscribed angle, so that means this angle is 16. This is 66 degrees. Now look, I have that inscribed angle, so that means that this angle is 33. Here, 114. Well, that's made by this inscribed angle. So that means 114 divided by 2 is 57 degrees. 66, the next one around, if I look, is formed by that inscribed angle. So that 66 comes down to 33. Again, I apologize for my handwriting here. And then last, I have this 82 degrees. That 82 degrees is formed by that inscribed angle. So 82 divided by 2 is 41. Now to get the rest of the angles on these inside, I'm just really going to use my triangles. I'm not going to write down all the values because I know that once we get one, we should be able to get the rest. But I'm really just walking through this. So I know that those two had to plus this one had to add to 180, so I subtract to get 73. Once I get that one, I get this one. 73 and 33, plus whatever goes here has to add to 180, and that measure is 74 degrees. So if that's 74, then this is 74. And 57 plus 74 plus this is equal to 180, so that is 49 degrees. That's 49, and this is 49. And I can subtract from 180 to get 98. Now, a couple of interesting things that I can do. I know that this is also 98, and if I've done this correctly, then this set of angles plus this one should add to 180 for the triangle. I can also use my arcs to test myself out. So, if this is 98 degrees, then this is 82. Well, if I look, this angle creates both this arc and this larger arc down here. So, if I have done this correctly, I should be able to say that 82 remember I put that question mark to say, well, I'm going to test this, is equal to half of this arc, which is 66, plus this arc, which is 98. And as I go through, I'll see that that is in fact correct. This is a nice little way of checking these things out. This is 164. That's a bad looking 6 there. So 82 is in fact equal to 82. If I've done this correct, it'll work out. Alright, so that's illustrative of a nice little way to check to make sure I'm doing things correctly. Okay, let's move to the back side of this worksheet, and problem number 3. Problem number 3 is an interesting one because it looks rather difficult until we actually see what's going on. To start us off here, I'm purely going to look at my angles that are right here. And I have some inscribed angles. That 22 is going to mean that it's going to that inscribed angle there, which means that this is 11. Well, that angle here also forms that 22, so that means this is 11. Here I have an inscribed angle that makes it 20, so that means that this is 10. The 20, and that means this is 10. That's pretty nice because now I've got some information about the way that these are formed. The next big thing that I need to look at is the fact that I have a set of congruent chords. This chord here gives me a 105-degree angle. Arc. That chord is congruent, so that means that this is 105 as well. And I know that there's 360 degrees in a circle. I always want to be looking for those easy answers. I always want to be looking for that 360 degrees in the circle. I know that those all have to add up to 360, so if I take 360 minus 105, minus 20, minus 22, minus 105, I'm left with 108. Alright, now I have a couple of angles that are inscribed that all form that same arc. This one there, here, and then also here. So all of these are congruent. Means this is 54, this is 54, and this is also 54. From here, it's just a matter of solving for the triangles. I'm just going to start in a spot 54, 10. That means this is 116. That means this is 64. So then that angle right there is 105. And then I'll see the same thing occur on the other side, about 105. And then I've got my next angle here, so 10, 105, that means this is going to be 65. And then 11 and 54, so that means this is 115. And obviously I can get the rest of these angles if I wanted. I'll just kind of quickly sketch them in. The important thing, though, that we see here is that as I'm going, I'm really using all of my geometric knowledge to solve this. You'll notice that I'm really not using a heck of a lot of information about circles, but rather I'm using it selectively, and I'm really using it only when necessary. Now, I can use it at any point that I want. For instance, let's take a look at finding this angle. Now, there are ways for me to find the measure of this angle using this larger triangle. I know the measure of this angle. I know the measure of this angle because this is 54. I can figure out that one, so I should be able to figure out this. But I also know that measure of that angle, and I'll call that x. And I do that just purely because it's a nice way for me to notate it. Measure of that angle is equal to half of this arc minus that arc. So 108 minus that arc there is 22 plus 20. So that's 42. And I can go through, solve that out. Excuse me, this is a parenthesis. So that's 33. Again, are there lots of different ways that I could have gotten to some of these answers? Definitely. It's very easy for me to start in possibly at the top and using the fact that I've got this 105, and the 20 to solve for this 115, knowing that the measure of this angle is equal to half of this arc plus this larger arc. There's lots of ways I could have gone about this. I'm purely just choosing one that works. You're able to do this in any manner that you would like. Okay, let us take a look at the last one. This last problem, it looks to be probably either the most interesting or the easiest of all of the ones that we've looked at. To the contrary, though, I think this is actually probably one of the more difficult ones of these. And let's take a look at why. If we look, we have very few inscribed angles. I've got this 52 degrees right here that is created by this inscribed angle. So I can go in and solve. Half of 52 is 26. I have this inscribed angle, 28, comes in to be 14. And then I have this larger inscribed angle. So I can see that this angle is formed by this arc. It means I need to go through and add it up. I'm using my arc addition postulate. Remember, we define the arc addition postulate as just the ability to add up arcs. Not a huge issue for us because, quite honestly, it's fairly obvious, but it is one of those things we need to think about. 54 plus 52 plus 16 gives us that larger arc, and I divide that by 2, and I get 61. From there, I'm going to start solving. I've got 61 here, and I need to get to this angle, I need to get to this angle. Well, I kind of come to an impasse because there's a lack of other things that I can do. I don't really even have a way to directly, with 360 degrees, solve for this arc or that arc. So I have to look to this angle. And if I follow this angle out, we'll trace it here, I notice that that angle intersects my two arcs. Well, I'm able to go in and find the measure of this arc just by adding. And I have the measure of the angle, so I should be able to solve for that arc. Let's do that. I'll call that x. So the measure of my angle, 21, is equal to half of this arc, which is 52 plus 16 plus 28, which, you have to forgive me for my poor arithmetic skills here. 52 plus 16 plus 28 is 96 minus x. And we go through and solve. So this multiplying by 2 is 42 is equal to 96 minus x. Negative x is equal to a negative 54. So x, of course, is equal to just 54. So I'm going to take that x out and get rid of that arc as well. It's kind of confusing to me now that I'm done. And put that in as 54. I'll go ahead and take out these highlighted marks as well. Excuse me. Alright, now that I have that 54 degrees, I can solve for my other arc, just using the fact that there are 360 degrees in a circle. Again, I always have that in my back pocket to use. So, 360 minus 54 minus 58 minus 54 minus 52 minus 16 minus 28, all those added up, gives me 98. From here, I'm going to look to solve some of these angles on the outside. Well, again, I look and I have two secants, two lines that intersect on the outside. So to measure this angle is equal to half of this minus that. So I'm going to go ahead and call that y. And I'm just defining these variables so I can keep things organized. If you're comfortable with just doing these on the calculator and plugging through with them, that's completely fine by me. This is just a way to keep things organized. I go through and I solve and I get y is equal to 19. Similarly, I have a tangent here and I have a secant. So we'll call this angle Z. So I know that angle Z is equal to half of this arc minus that arc. So let's write that out. 1/2 of this arc, which is 54 plus 58, which is 112, minus 52, this arc. And we calculate that out, and I get 30. Well, put that in. Okay, so all along here, I'm using these methods. I'm looking for things that I know. I'm looking for things that I recognize. I'm using some of the methods that we've developed in class, and I'm using the fact that I have triangles. So let's finish out the rest of my angles. I've got a triangle, so 19 and 61 should give me a value that I can subtract from 180 to get to this angle, which is in fact 100. And I've got 100, that means that's 100, that's 80, and that's 80. Now, two things that I can do here. I can solve for the measure of this angle based on the fact that it cuts some arcs. I can also solve for the measure of this angle using this triangle. Now, I want to look at the measure of the triangle first, which 30 plus 80, subtract from 180, means that this is going to be 70. But I also want us to take a look at how we would solve for the measure of that angle if we chose to use arcs. Okay, so I'm going to call this W. Oh, that's a bad looking W, I apologize. And let's solve. So that angle creates these arcs. So it means that W is equal to half of this larger arc minus this smaller one. So the larger arc, let's look. That is 98 plus 28 plus 16 plus 52, which is 194. Minus the smaller one, which is 54, and we get half of 140, excuse me, which is equal to 70, which is what we got before. Either of these methods is fine. Sometimes it's easier for us to work with the arcs because it's hard for us to sometimes decide what triangle it is that we're working with, especially in a situation like this where I have this larger triangle, but then I also have this angle in the smaller triangle. Well, from here, I have several options as to figuring out the measure of this angle. I could use my triangles, but I want to use the arcs just for the sake of argument. This angle, if we notice, is formed by a tangent and then this line. We notice that the vertex is on the edge, so then that means that the measure of this angle is equal to half of this plus this. Remember, we regard it like it is an inscribed angle. So 54 plus 58 is 112. Half of that is 56. 56 and 70. If I subtract from 180, that is 54. I can check that. This angle creates both this arc, and in fact those arcs are the same, so that has to be 54. From there, I check 116, 54, and if I've done things correctly, my triangle on the inside adds up to 180. 100 plus 54 plus 26 is equal to 180. And that is all of those angles and arcs. Now, I've gone through and I've shown you some of the checks. I've walked through this process with you. Understand that on the mastery test, you are not going to see problems that are this intense or will involve this many unknowns. That being said, again, we're looking at the methods. You're using these same methods over and over again for these problems. If you get into a situation where you don't quite know where you're going, just start in a spot like we did on these problems. Start and then slowly work our way through. All the information will be there that you'll need. There's nothing that will be lost. Keep calm with it. Know that there is an answer and persevere. And with that, I tell you, have a good rest of the day and happy studying.